Linear equations part 2. This part's a little bit shorter. We're just going to learn two things in this part. First, learn how to graph horizontal and vertical lines by using their equations. And second, learn how to write the equation of a line given a point and another line that is parallel to that line. So first, want to make sure you know what the equations for horizontal and vertical lines looks like. A horizontal line is always of the form y equals c, or y equals a number. So you see some examples there. Y equals 2, y equals -5, y equals pi. Anytime it's y equals a number, that is a horizontal line. Which, if you remember, we said horizontal lines are ones that have a slope of 0. So think about the equation y equals mx plus b. If you plug in 0 for m, our slope, you just get y equals b, and b is a number. It's the y-intercept. So y equals b, y equals c, both mean y equals a number. So whenever you get y equals a number, it's a horizontal line. Vertical lines are always the form x equals c. So x equals 1, or x equals -3, or x equals 50. So that's a vertical line. Notice it has no slope. It's also called undefined slope. These are also not functions. If you remember from a previous math class, you probably learned that you could use the vertical line test to determine if something was a function. Well, a vertical line is certainly not going to pass the vertical line test since it is one. If you try to pass a vertical line over it, it's going to hit every single point in the whole thing all at once. So these are not functions. So you've got to remember horizontal goes with y equals a number, and vertical goes with x equals a number. So now we have write the equation of the line that passes through -3, 2 and is parallel to y equals 2x plus 1. So remember, in part 1 I talked about the fact that you have to know, for an equation of a line, the slope and a point. Well, they very clearly have given us the point, and they have implicitly given us the slope. In other words, they've given us information to help us find the slope. The key word here is parallel. If there's nothing else you remember for this course about the word parallel, you need to remember that it implies that two lines that are parallel have the same slope. So what you've got to connect in your brain is parallel means they have the same slope. Parallel, same slope. So hopefully at this point you can just look at this equation and tell, hey, its slope is 2, because the slope is always the coefficient of x. So now we very clearly do have a point and a slope. So using my method, the point-slope form, we get y minus 2 equals 2 times x minus -3. So two negatives make a positive, and we get y minus 2 equals 2x plus 6. Remember, you have to distribute the 2, and then you just add 2 to both sides to get y equals 2x plus 8. So that's how you find the equation of a line given a point and a line that's parallel to it. This example is almost the exact same thing, but it's got a little bit of a twist. Our parallel line over here is not written in the y equals mx plus b form, so it's not easy to just look at it and tell what the equation would be or what the slope would be. So we're going to have to solve for y, get it in y equals mx plus b form so that we can tell what the slope is. So I'm going to subtract 2x from both sides and get -6y equals -2x plus 12. Okay, now if you want, you can write that as 12 minus 2x. That's the same thing, but since we always have the form mx plus b, I'm just keeping it in that order, in that form. But 12 minus 2x and -2x plus 12 are the same thing. And then we need to divide everything by -6. Everything. So that cancels that out, leaving y. -2 over -6 is 1/3. And 12 over -6 is -2. So our slope is going to be 1/3, because we know parallel means they have the exact same slope. So my slope is 1/3, and my point is 7, 1. So I do y minus the y value equals m times x minus the x value. So then I distribute the 1/3 through and add 1 to both sides. And that concludes linear equations, part 2. There is one more part, part 3, that will be posted later.